What's up YouTube, it's LDS Reliance. Today we're going to do another video on the liquid-cooled Peltier fridge build. It's been a little while since we've messed with this, and as I promised before, this is not on the shelf. This is going to be improved upon, and today what we've got is we're going to introduce a thermostat into the mix. So what I have is a 12-volt thermostat. These are cheap, that you can get on Amazon or eBay or whatever, and they have a temperature probe that plugs in there. And so basically you put the probe inside of it, you connect the power source in here, and then it goes out into the fridge, and so when it reaches a desired temperature it turns off the power. So this should theoretically save us some power and allow us to reach a set cooling point. So that's what we're going to test today. So let me show you what we've got here, and I apologize for my sniffles. We've got a watts up meter, which is basically a device that measures the power and logs how much power you're consuming. So that's going to be important to this test, because I want to make sure that this thermostat is actually going to save us power over time. We've got our do-it-yourself power source made from a computer power supply. If you haven't watched that video, go watch it. Really easy to make and provides good, clean, steady power, and that's why we're using that for this build. We don't want to mess with any battery voltage drop or any of that kind of stuff. You'll probably notice on top, and I'll zoom in and show you all this stuff anyway, but we've got a separate, this is all separate to everything else, but this is just a temperature gauge that we're going to snake the probe in there just so we can kind of see what the temperature is without opening the door. As always, you probably can't see it, but I've got the USB data logger for the temperature in there, so we'll be able to also see a graph like I like to do, kind of see what it's doing over time. And that is powered by this little battery here, so it's not being powered by this. It's not going to affect our power consumption readings or anything like that. So what we're going to do first is I'm going to take a baseline test. I'm going to run this for an hour without the thermostat connected. We're going to take our logs. We're going to see what we get there and what we get power consumption wise, and then we're going to use that as the baseline. Then I'm going to plug this thing in, and we're going to let this thing warm back up, because we want to make sure that you know, that it's back up to ambient temperature, so that we eliminate any variables here. And then we're going to wire this in, turn it on, run the same thing for an hour at a set point here, and we'll see how that compares with the baseline test. So let's go to it. Okay, so I had to swap out batteries there because the other one was kind of dead and the meter stopped working. But anyway, we've got everything buttoned up here, plugged in, ready to go. So you can see we're using 0 watts right now. So let's go ahead and turn on the power supply. Okay, so that's on. Now we are pulling 126 watts. So I will check the time right now. It is 12:45, so I will check back in an hour. It's already dropping there, as you can see. It was 31 a second ago, and we will let this run for an hour, get the data logs, and check the power consumption. This has a kilowatt hours reading. It might be kind of small, but we'll be able to tell how many kilowatt hours have been consumed, and then we will switch over to the thermostat and compare that. All right, it's been an hour, so let's see what we got. It doesn't look like, according to the temperature there, 15.6 Celsius, it's about 60 degrees Fahrenheit, so that's not too promising. But let's go ahead and shut it off and take the temperature logger in, and also see how many kilowatt hours we consumed. All right, so we're turning this off. So as you can see, we are no longer consuming any watts. and we have used 1.12 kilowatt hours. And the coldest we got was 15.6 on that probe, but this one's the more important one. It feels cold. So let's take this in and take a look. Okay, so as I was afraid of, this confirms the temperature probe on top of the fridge that the coldest it got was 63 degrees on the inside. So I'm not sure what's going on there, but we can still test the thermostat. We can still get a valid test. I just need to set the thermostat set point for, I don't know, 70 degrees or something like that, which I well know is not a appropriate temperature for a refrigerator, but I'll worry about that another time, figure out what's going on there. But anyway, so here's what we got. It got down to 63 degrees, and we already showed how much power it consumed, so now let's wire up the thermostat and check that out. Okay, so we've let this thing sit to get back up to ambient temperature here for at least an hour. As you can see, we're back to 31.7 Celsius, and our thermostat, I should say, is connected here, and it shows 31.6. So we got a pretty good correlation there. This wiring's a hot mess, but the thermostat is drawing power from these batteries, so it won't influence the power consumption numbers. And we have reset the kilowatt hours to 0, as you see. So I've started the data logger. We're gonna close the door and turn this thing on and give it an hour just like the other tests and see what happens. I've set, before I go, I have set the thermostat to 70 degrees Celsius, or 70 Fahrenheit, which is 21.1 Celsius. So that will be the set point, and we'll make a comparison and see what we get. Okay, I just wanted to show that this thing is turning on and off. So right now we are at 112 watts, and we're at 19.5 Celsius. So I just wanted to show here in a second, this thing's going to turn off. The thermostat's going to cut the power and won't kick it back on until it gets back above the 21.1 set point. Okay, there it goes. So once it hit about 18.8, as you can see, the only thing that's running right now are the pumps and the fans. So when that's creeping back up already, once that creeps back up to about 21.1 or so, it will turn everything back on, and so it's working pretty well. All right, so it's been an hour. I'm going to go ahead and turn the power supply off. So you can see watts have gone to 0, and we have only consumed 0.07 kilowatt hours. So just a little over half of what it took to run the other one the entire full hour. So let's go ahead and pull out the data logger and take it inside and see what we got. Okay, so we can see here that the refrigerator got down to 70 degrees, which is 70 degrees Fahrenheit, which is 21.1 Celsius roughly, and then stayed there. And it was actually much more steady than I anticipated that it was. It stayed, stayed under 70. So anyway, I was expecting to see some up and down a little bit here, but that's quite interesting. Maybe because the logger was on the bottom of the refrigerator and the little probe for the thermostat was towards the top. That could explain it. But anyway, interesting results. We did save about 40% or so of the energy over just running the Peltier wide open at all times. so that's a positive. And it would have been even more of a savings if we'd run it longer, because obviously the most of the energy is just getting it down to operating temperature after you've had the door open or whatever, and then keeping it here takes much less energy. So I'm really encouraged about this. I am quite annoyed that I wasn't able to get it down to the 40 degrees Fahrenheit that we had it before. Not sure what's going on with that, but I'm going to figure that out, and we'll just keep making this fridge better. But the thermostat's a win, and thanks for watching, guys.